Welcome to doassignment-ca. Here is the problem. A particle moves through an electric field between two plates. Its velocity-time graph is a symmetric triangle, where t' equals 0.2 seconds and Vmax equals 10 meters per second. Velocity increases linearly from 0 to Vmax over the first half of the time interval, that is, from 0 to t' over 2, then decreases linearly from Vmax back to 0 over the second half, from t' over 2 to t'. At t equals t' over 2, which is 0.1 seconds, the particle is at position s equals 0.5 meters. Draw the s versus t and a versus t graphs for the particle. Now let us work through the solution step by step. The velocity time graph is a triangle. In the first half, from 0 to 0.1 seconds, velocity rises linearly from 0 to 10 meters per second. In the second half, from 0.1 to 0.2 seconds, it falls linearly back to 0. The slope of each segment gives a constant acceleration, and the area under the curve gives displacement. For phase 1, acceleration equals the change in velocity divided by the change in time. That is 10 minus 0 divided by 0.1 minus 0, giving positive 100 meters per second squared. So during phase 1, velocity equals 100 times t. For phase 2, the slope is 0 minus 10 divided by 0.2 minus 0.1, which equals negative 100 meters per second squared. The velocity in this phase is negative 100t plus 20. The acceleration time graph therefore shows a constant positive 100 in the first half and a constant negative 100 in the second half, with a sharp jump at the midpoint. Integrate velocity 100t to get position. The antiderivative is 50t squared plus a constant. Using the condition that s equals 0.5 meters when t equals 0.1 seconds, we substitute and find the constant is 0. So in phase 1, position equals 50t squared. Checking at t equals 0 gives s equals 0, which is correct. The particle starts at the left plate. The position curve in phase 1 is a concave up parabola because the acceleration is positive. For phase 2, integrate negative 100t plus 20 to get negative 50t squared plus 20t plus a constant. Applying the continuity condition that s equals 0.5 at t equals 0.1 seconds gives the constant as negative 1. So in phase 2, position equals negative 50t squared plus 20t minus 1. Plugging t equals 0.2 seconds into the phase 2 position equation, negative 50 times 0.04 plus 20 times 0.2 minus 1 equals negative 2 plus 4 minus 1, which equals 1 meter. The maximum displacement between the plates is 1 meter. The phase 2 curve is concave down because acceleration is negative. To summarize, the position time graph consists of two parabolas joined at the midpoint. The first is concave up, going from 0 to 0.5 meters, and the second is concave down, continuing from 0.5 to 1.0 meters. They meet smoothly because velocity is continuous at the junction. The acceleration time graph is simply two horizontal lines, positive 100 meters per second squared in the first half and negative 100 meters per second squared in the second half, with a jump at 0.1 seconds. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.